So the last time we started with a function. Just give me a second. Let me scroll the function, scroll up to the function. Yeah, 10x cubed over x squared minus 1. And let us quickly see what are the informations we had. So we know that domain, we know the vertical asymptotes, we know the function is odd. We also know the critical points and the intervals where it's increasing and decreasing. Okay. So first of all, our function is 10x cubed over x squared minus 1. We know the vertical asymptotes are at -1 and 1. Obviously, x equals -1 and 1. And we have critical points, or at least when we set this to 0, we got x equals plus minus square root of 3 and plus minus 1, right? This is not really for setting this to 0, so I should write it separately though. This was where the derivative does not exist, right? The derivative does not exist at this point. So we have 4 points from the first derivative. Okay, so these are the critical points, and this is where the derivative does not exist. Okay, now for the intervals, if you remember, we subdivided it using these points, right? Let me rewrite it quickly. -infinity to -square root of 3, -square root of 3 to -1, -1 to 1, 1 to square root of 3, and square root of 3 to positive infinity. Okay, and if you remember, it was increasing for these two parts, these two intervals, and decreasing for all three of these, right? And we also know the slant asymptote, right? We know that since the degree of the numerator is higher than the degree is one more, in fact, is one more than the degree of the denominator, then we have a slant asymptote, right? And how to find it? Again, a quick reminder, you just divide it, nothing else. Sorry. You just find the quotient for this fraction, nothing else, okay? So that is x squared minus 1, and we are dividing a 10x cubed by it, okay? And fortunately, it is an easy one. If we just multiply it by 10x, we get 10x cubed. We have additional terms though. We have additional terms, but this is definitely going to be the quotient. And or whatever we have here is going to be the remainder. So y equals 10x is our slant asymptote. That's how we get it. So now let's try to draw the graph again. We have an asymptote at -1 and +1. So let's first draw that again. Okay, let's just imagine that these are my asymptotes at -1 and +1. We also have a slant asymptote, y equals 10x. It should look like this. As I draw the second half, it should go this way. Anyway, yeah, let's just imagine, because we are drawing it in using just the measurements. We're not really drawing it properly. Okay, so these are the informations we have initially. Now, to see this, let's find out square root of 3. Let's say that's my square root of 3, negative square root of 3, and that's my positive square root of 3. And I know that before, or rather until square root of -3, my graph is increasing. That means it will either look like this or look like this. We know we can find increasing function two ways, right? Either this, like this, or this. Sorry. Okay, now the question would be, which one should I pick, right? And for that, we need concavity. If we know whether it's concave up or concave down, then we can actually do it easily. Okay. Okay. So for that, one way is to find the second derivative and set that to 0, and then solve it for x, right? And then whatever we have for x, we can subdivide our intervals using those values. Another way I thought we can do is just check the second derivatives at these intervals. We can actually do that. I actually thought after we finish the last time that yeah, the general idea is to set the second derivative to 0 and solve it for x. But what if it's really complicated, like the one we had yesterday? So then I thought we can actually find the second derivative and look how it behaves in these intervals rather than setting those to 0. Let's try this now. So we know the second derivative. And now your job is to find how it's behaving in those intervals. And if you remember, the second derivative was, here you go. This is the second derivative, right? Now you just need to find how it's behaving in those intervals. In other words, you just need to plug in values from those intervals and check whether it's greater than 0 or less than 0. Okay, so let's try one by one. I'd like one of you to help me with the calculation. Using the calculator, of course, you don't need to use, you don't need to go for hand calculations anyway. So the first interval was from -∞ to -3. So which point should we pick? Which one do you think would be easier if we pick from that interval? We don't need to go for any really good looking value. Whichever value will give us the result, that should be fine. The closest one I can imagine is -2, right? from negative 3 to negative square root of, sorry, negative infinity to negative square root of 3. Can we pick negative 2 from that? Let me rewrite the intervals for you. Hopefully it will make more sense. Maybe you can't really see what's going on. Okay, the interval I'm talking about is negative infinity to negative square root of 3. My question is, which point should I pick from this interval? Anyone? Is anyone trying to say anything? I can't hear anything though. Let me ask from the participants list. James, can you hear me? James, are you there?
Hello, can you hear me?
Yeah, I can hear you. Yeah.
Sorry, can you say your question again? You're kind of breaking up.
Really? Is my audio not working?
I think it's just for me. My internet sometimes cuts out.
Okay. So my question is, as you can see it on the screen, from this interval, which point should I pick? I mean, is there any restriction or anything that makes my life easier or something like that? I'm just trying to check how the second derivative is behaving in this interval. So which point should I pick? Just give it a try. No worries. It doesn't need to be right.
Let me think one second.
Any guess?
Maybe -1 since it's, would that be the easiest?
Okay, -1 would be the easiest, but the question is, does -1 falls into this interval? Does it lie in that interval?
Yeah.
No, it does not. The negative square root of 3 is actually negative 1.73.
Oh, okay.
Right? Yeah, that's why I asked this question, because from my previous experience of teaching Calculus 1 as a TA, I was not the instructor though, but as a TA, I had to do discussion classes. So I saw picking up these points was often tricky when we had rational functions, rational values like this. I should say irrational, not rational, sorry. When we had irrational values like this, like square root of 3, like even for fractions, for example, 9/5. I'm just giving an example. When you don't have a straightforward value, often we do a mistake like this, and that's quite common. You don't need to get demoralized, or you don't need to think, oh, what I'm doing. No, it's not like that. It happens simply because often we get carried away by thinking that, hey, looks like this value falls into this interval, but it may not. So we need to cross check it, right? Okay, now anyone else? Can anyone tell me which value should I pick? I actually gave you a hint.
I would use -2 because it's just right there.
Yeah, so when I was a student, my pick was the smallest one always. I used to pick the smallest value always, since the smallest value is always easier to calculate. If I can pick one, -1 and 0, that's the best, but often we can't really pick that. So what I used to do is pick the smallest possible value. Again, as I said, because it's easier to calculate. Although for this one, -2 is still would be really a big one. So let's try that. -2, if I pick it from this interval, it would be 4 minus 1 here, and squared will be 9, and this would be 40 times 8 and 60 times 2. So what's 40 times 8? 320. And 60 times 2 is 120. So it's actually 200. 9 times 200 is 1800. So for this part, we have 1800. Does it make sense? Am I doing it really fast? I'm just doing the calculation. You can use the calculator. I don't have mine with me. That's why I'm doing the hand calculation. If you have the calculator, just use it and find the value, okay? And 2 to the 4 is 16, I believe. So it's 160, and it's 120. So it is going to be 40 for this. Oops. 40 for this part, and then 8 and 3 from this. So 8 times 3 is 24. So 40 times 24. Can anyone tell me the value? 40 times 24. I think it's 960. Is it?
Yes, sir.
Okay. And if I subtract 960 from 1800, it's greater than 0, right? I don't even need the value. All I need is whether it's positive or not. And it's definitely positive. Do you agree? Right? So it's concave up for this part. What is the graph? And well, did I do it right? Oh, no. I did a mistake. No one really noticed. I actually calculated for +2. Yeah, that's why I was wondering, because it should be less than 0 for this part. It should be concave down. Okay, so did anyone do this for -2? I actually have it for +2. So I can use it though. I'll have one of these intervals where I can use +2. Okay, who has calculated for -2? Anyone?
I did, but I don't think it was right.
No worries, go for it. What did you get?
I got, like, for the top part, I got 2,344. So I think I messed up somewhere, because if you said it was supposed to be negative.
Yeah, I think it should be negative. Yeah, definitely.
For -2, I have -280.
-280? Very good.
Yeah.
Okay, yeah. That should be right, because as I said, for this part, the second derivative should be negative. So for -2, since it's less than 0, that's for -2, by the way. Okay. Our second derivative is less than 0, so it's concave down, right? So for concave down, how does the graph look like? Is it this one or this one? You can see how many things you need to combine all together to draw this graph, right? It's fun to work with, but it's really, really, tricky sometimes, since you need to combine, a whole lot of things together. So for concave down, we know the increasing function has a loop has an outlook like this, either the upper one or the lower one. And now we need to pick which one we need to draw. And the additional information we have is the function is concave down. Now which one should we pick? We know how does the concave down function look like. And you need to pick it really quick, otherwise you might be running short of time, right? So since it's probably the first time I'm going to show it, but for the exam, for the homework, not for the homework though, but for the exam, you need to pick it really quick, okay? So this one is for concave down. And if you're wondering why, let me quickly give you a reminder. As you can see, let me draw a bigger version of it here. You can see the tangent is getting smaller. If you draw a tangent at each point, you'll see the tangent is getting smaller. The slope of the tangent, of course, is getting smaller. That's why it's concave down. Again, you need to combine all these concepts together, right? That's the most difficult part, if any, for this graphing functions. So we are going to draw like this up to negative square root of 3. We'll keep it like this, okay? And then for the next part, I'm not going to repeat it. I've just showed how to do this. You just need to find the same way. You just need to find it for the other intervals as well. Okay, like the way you have done it for the first derivative, you just need to find it for the second derivative as well. Okay, I already know for this one, it was positive when I picked up 2, right? 2, oh no, 2 does not lie here. Sorry about that. See, I was doing the same mistake.
I have a question.
Yeah, I'll give you a chance. Just give me a second.
Okay.
So it's from square root of 3 to infinity, and 2 definitely lies here. And for that, we know it was positive. You just need to find for the other parts. Yeah, now go for it.
Why isn't -1 to 0 and 0 to 1 also included in the integrals? Because isn't x equals 0 another 0?
What do you mean by another 0?
You don't have like x equals 0 as one of your points. I'm just a little confused on why that is.
We actually set up intervals where yeah, you can definitely find, or rather use another interval here like this, -1 to 0 and 0 to 1. Yeah, we can do that.
Okay.
Definitely. Yeah, you can always subdivide it more into more parts. Yeah, I think that would be even better, but you can still do it without it. Yeah, that's a good point. I think you can add that, especially when you are doing it for the first time. Since you have a 0 at 0, by 0 I mean a root. That means the graph is going through that point. And how do I know that? I can actually get it from the x-intercept. So our function was 10x cubed x squared minus 1. So our x-intercept, that means when y is 0 or the functional value is 0, we know it will be 10x cubed equals to 0. So x will be 0. That means your graph will go through that main point or origin, we say. It will go through the point 0, 0. Okay, yeah, you can subdivide your intervals like that. -1 to 0 and 0 to +1. That will take more time, but yeah, that would be even better. Okay, so if you follow this procedure, so for this part, you have concave down, you have concave up. For this one, if you find the other three parts and follow this procedure, you'll be able to draw the entire graph. Okay, I've already shown it the last time, and I actually got it using this procedure. Okay, whatever I did here for the first part, it's the same thing. Okay, any question from this one? Because now I'll give you a graph like this, I mean a function like this, and then we'll try to find the graph of this. I'll give you a function, and then together we'll work on that. Okay, any question from this one? Okay, let us quickly go for an honest opinion. How many of you have tried it after you finished the last time? Because you already know what are the things you need to do, because we know it from the guidelines, right? And I have actually briefly discussed it before we started. And even I finished it without describing how did I do that. I left it for today since I was running short of time. So I expect at least some of you to try it, at least to give it a try. And that's the way to do calculus, right? You need to practice a lot, at least a couple, if not more. So spatially from this section and ideally the next one, obviously the next one, I would say, once we are done, I'd recommend you guys to practice straight after, because your memories, your concept will be fresh. Once you are done with the discussion, you have just finished observing a or you have just taken a part um, in the discussion. So it will be really a convenient time for you, especially the next chapter, as I said. Once we are done today, I'd recommend you guys to practice or to see one or two problems, just to make sure you use your fresh memories for that. That would be really good. Anyway, let's try one problem, and hopefully it will make more sense and it will be more convincing. So no questions from this problem. Is there any question from the way we need to do? That means the procedure we need to follow for it. No questions at all. Okay. Let's try a problem, and then we'll come back to the questions, if any. Okay. Which one should we try? Let me generate one for you. Okay, yeah, let's try this one. Let's try an easier problem. The function is x cubed minus 18x squared plus 81x. Okay, these are the, my laptop keeps freezing. Okay, yeah, this happens. No worries, okay? All right, so this is the function we have, and we want to graph it using the graphing guidelines, okay? So I'll take answers from you one by one. I'll not do anything. I want you to contribute, and I want you to know how to do it, okay? If I do it, and if you just observe it, this might look easy. Okay, so what's the first thing we need to do? And I'll take answers from everyone, okay?
Need to find the domain.
Okay, so I already have one answer, which is to find the domain. Okay, so Hannah, I think you said that. So can you locate the domain for me for this problem? What do you think should be the domain for this problem?
Is it all real numbers?
And why do you think like that?
I don't know.
Yeah, go.
Well, it doesn't have,
Fine.
like, I first thought it because it doesn't have, it's not a fraction, so it's a polynomial.
Exactly. Very good.
Okay.
Since it's a polynomial, all real numbers from negative infinity to infinity is the domain. Very good.
Thank you.
Okay, so someone else, not Hannah. As I said, I'll take answers from everyone. What should you do now? What should you do next?
We find the first derivative.
Okay, we can do that. Let me find the first derivative for you. Okay, so I couldn't notice your name. Is it Cole?
Yeah.
Okay, so can you tell me the first derivative for me for this function?
It'd be 3x squared minus, what's that? 36x plus 81.
Very good. Yeah. Using the power rule, for this one it will be 3x squared. For this one it will be 2x, but we have an 18 multiplied with that, so it will be 18 times 2x, which is 36x. And for this one it will be 81, right? Okay, so we have found the first derivative. Okay, now someone else other than Cole and Hannah. What's next? What
And the
should
critical points?
sorry? I couldn't understand.
I said find the critical points of it.
Okay, and what should we do for that?
Set it to 0.
Set this to 0. Okay, you can set this to 0, and if I do that, I shouldn't use this sign here. Okay, so it will be 3x squared minus 36x, oops, plus 81 equals to 0. Okay, Matthew, so you can continue. What should we do now? We have a really big, not that big, but quite biggish equation to solve. What should you do?
I factored out a 3 first.
Okay, yeah, very good.
So I get 3 times x squared minus 18x plus 27.
No, it shouldn't be 18. It should be 12.
Oh, you're right, 12. My bad.
Yeah, no worries. Okay. Okay, what's next? Now what should we do? We still have this to deal with, right?
Yeah, so it should factor out to x minus 9, x minus 3.
Very good. Yeah. It should be x minus 3 and x minus 9. Yeah, you're right.
So we will have critical points at 3 and 9.
Exactly. We have critical points at 3 and 9. All right. Okay, thank you. Now we have the critical points. And before going for the second derivative, I want to subdivide the interval into um, I want to subdivide the interval using these critical points. So now, someone else, can you tell me? Um, so Matthew, Hannah, and Cole have already answered. Someone else from the participants list. We're not too many today, to be honest, 11 in total. So can anyone tell me how can I subdivide the intervals using this? Okay, I think I can, other than asking like this, I can start picking up.
I'm
Okay,
kind of confused what you mean about subdivide, but would it be like -infinity to 3, and then 3 to 9, and then 9 to infinity?
exactly, yeah.
Okay.
And how did you do that? Can you please explain?
Well, we know that our domain is all real numbers,
Mhm.
and then our critical points are 3 and 9. So then you just kind of put them in order.
Right, so we start from the very left. We come to the first point we have encountered. Then we start from that again and go for the next point we can see, and we keep doing it like this, right? So the first point we can see from the real number line is 3 when we start from negative infinity. Since our domain was negative infinity to positive infinity, right? And our critical points are 3 and 9. So we start from negative infinity. We come to the first point we have, which is 3. We stop there. And in the next interval, we again start from that and go for the next possible point, which is on this occasion 9. We stop there. And then we start from 9 and go to the next possible point, which is the positive infinity. We don't have any other points to check, to be honest, right? We can always find the 0 and subdivide our intervals using that point as well. We can do that. Excuse me. Let's check the 0 as well. Let's just check. If that's 0, means x cubed minus 18x squared plus 81x is 0. If I solve it for x, what do I get? I'll definitely get a 0 because I can factor out 1x from it. So this will definitely give 0 as a 0 for this function. What else? I think I'll get 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 might be another 0. Let me see. So if I factor it out, if I factor x from that, it will be x squared minus 18x plus 81. And if I solve this, what do I get? So I can use this rule, which is minus b. So 18 plus minus 18 squared minus 4 times 1 times 81 over 2a. Can you calculate it for me? What are the possible values from this calculation?
Let's get x minus 9 squared.
Oh, okay. Yeah, this could be x minus 9 squared. I should have checked, but I didn't want to waste time on this because it's algebra, not calculus anyway. Yeah, you're right. It's x minus 9 squared. Very good. Yeah. Thank you. So this is x minus 9 squared. So that means x equals 0 and x minus 9 squared equals to 0. So x equals to 9. Okay. All right. So we have zeros at 0 and 9. We'll use this later. Okay. All right. So we have the domain, we have the intervals now. What should we do next?
Is this where we find the second derivative to find the intersection?
We can find the second derivative, but since we know the intervals, we can actually finish it here and go for the second derivative so that we don't need to come back here again. So we want to find on these intervals where the function is increasing and where it's decreasing, right? So Ada, I think you asked the question. So can you please carry on from here? What's happening on this interval? I'm talking about the increasing and decreasing part of the function. First of all, what should you do to check whether it's increasing or decreasing?
Would we plug in the 3 and 9 back in the equation?
No, we can't really plug in 3 and 9. If we plug in 3 and 9, it will be 0 because we have calculated for the 0. We can't really plug in 3 and 9. First of all, we are considering this interval. So which point should we pick? Again, this could be tricky, although we have a straightforward value for this. But still, we need to understand which one should I pick. I mean, how do I pick, right? Can't really pick any value. Can we pick 3? And the answer is no, because it's open interval, right? So the value 3 is not included. We can't really input or plug in a value which is not included in this particular interval. These 3 open parentheses, open interval or parenthesis means this 3 is not included. If there's a bracket, then we would have plugged in 3 because that would have meant that 3 is included, but that's not the case here. Now, can you tell me what should I do?
Oh,
Yeah.
could we do like 1 since that lies in between?
Yeah,
The negative
1,
infinity to 3?
1 or even 0, right? We can even pick 0. Can you see that? Because 0 definitely lies here. Do you agree? So we can actually pick 0
Yes.
from it. So if we pick 0, now the next question would be, it's really a silly one, but I think I should ask, where should I plug it? I know I can pick a 0 from this interval, but my question is, where should I plug it back? Is it the main function, the first derivative, the second derivative, where?
Would it be the second derivative?
Not really, because we are trying to find where the function is increasing, right? We're not really trying to find where it's concave up or concave down. But thanks for pointing it out. Yeah, so when you are trying to find where it's increasing or decreasing, plug it back to the first derivative, okay? When you are trying to find whether it's concave up or concave down, then plug it back to the second derivative. Okay? So now if I plug it back to the first derivative, this will be 0, this will be 0, we'll have 81. So our function will be increasing in this interval, right? Since 81 is greater than 0. Do you agree? Let's try the second interval. Which value could we pick from this interval 3 to 9.
Five is a good one.
Yeah, in the 5. I was gonna say 5. But
Okay, and what does it give us when you plug in 5 into the first derivative?
Gives us a negative value.
Negative value. Okay, so that means it's decreasing. Okay, and from this one we can pick a 10 maybe, right? And if we pick up a 10, what does it give us? So it is going to be 300. It's going to be a 360. So 300 plus 81, so 381 minus 360, it will be positive. Is that right? Do you think that's right?
yeah,
We can plug in 10 from it, right? 10 would be a great value. It's easier to calculate. It's easier to find the squared value as well. So I picked up a 10. And you can pick 4 from it, 5 from it, whatever from this one. You picked up 5, that should be still fine. No worries. So we now know where it's increasing and where it's decreasing. Next, we need to find the second derivative because we need to check the concavity as well, right? Okay, so what's the second derivative of this?
6x minus 36.
So let me write the first derivative again. So 3x squared minus 36x plus 81, I believe. Yeah. So yeah, so if we find the second derivative, this will give us 2x. We have a 3 here as well. So 3 times 2, that's 6x. And there is a 36 from this. So the second derivative is 6x minus 36. Okay. And again, we'll check these intervals, what's happening to this second derivative on these intervals, right? So once again, we can pick the same 3 values for it. If we pick a 0 from the first interval, this will be 0. It will be negative 36, right? So the second derivative is negative in the first interval. What does it mean? It's concave. Is it concave up or concave down? Kaylee, can you tell me the answer? Just give it a try. No worries.
Concave down.
Exactly. Since the second derivative is negative, it will be concave down. Very good. Same. Let us try the same thing for the other 2 intervals. If we pick 5 for this, it will be 5 times 6, which is 30, minus 36 would be negative, right? So it will still be concave down in this interval. And if we pick 10, clearly it will be 60 minus 36. It will be positive, concave up. Do you agree? Okay. Now we have all the informations. Now let us try to draw this. Oops, it's too big. It should be fine. Okay, now we know from negative infinity to 3, it's increasing and concave down. So should it be like this or like this? Again, a quick question. You need to
It's gonna be like the one on the left that you drew.
Exactly. Obviously, for increasing, these are the 2 possible ways you can draw it. But for concave down, this is the one, right? since you can see the slope is slowly and slowly going to the lower value. So that means up to 3, right? So let's say that's my 3. And we know it will go through 0 because we have a 0 at 0 and we have a 0 at 9. It's actually 9, 9. I'll explain why it's 9, 9 and what does happen when we have a 0 like this. Here, 0, I mean the root, okay? Not the value 0. Okay, so we know it's concave down, so it will go like this up to 3. Up to 3, is it? Yeah, up to 3. So that's my 3. I know it's increasing and concave down. Oops, it didn't really touch the 0. It's difficult to draw a graph by hand though. The good thing is you'll be given options for this. You'll not be asked to draw this anyway. Yeah, it will look like this, right? Do you agree? Use the object eraser. Okay, yeah, it will look like this for this first interval. Do you agree? I don't want to proceed before you agree with this. You don't need to trust me. You just need to see actually is this happening or not. First of all, it's going through the value 0, x equals 0, definitely, since we have a root there. So that's why we have picked this one. We went through 0. And we have increasing and concave down up to the value 3. So that's my 3. So this should look like this. Do you agree? Is there anyone who does not agree with this? Don't hesitate, okay? Even if you think that might be a silly question, please ask. You never know, that might clarify someone else's misconception as well. You never know which could be a good question, okay? All right, now the next thing is it's decreasing and concave down from 3 to 9. So let's say, oh, I think I need more space here. So let's say that's my 9. And it's decreasing and concave down. So for decreasing, it could be either this or this. Now, which one should we pick for concave down?
The one on the right.
Exactly, again, the same reasoning behind this. For this one, for concave, we have concave down. So that means our, should I say, our function or our graph, I would say, should look like this. So we'll go to 9. Okay, we'll stop here because we can see we have a double root here. What this could mean? This could mean either, not either, this could mean your function is actually touching that point and not going through, okay? If you have a double root at a certain point, that means your graph is not going through that point, unlike the other roots. Like for 0, I can see my graph is going through this point. But since we have a double root at 9, this will mean our function will not intersect 9. It will not go through 9. It will just touch it, and then it will bounce back to the same or to the same part of the x-axis. It will not go beyond this x-axis. It will not go beyond this line. It will just touch 9, and it will go back to the same part of the x-axis. That means the positive. I should say the upper side of the x-axis. right? Okay. Now let's see what's happening for the last interval. So we have increasing and concave up. Okay, so increasing and concave up. Did I do that? Yeah, that means it will look like this, right? This one was for concave up. So our function will look like this. That's it. That's your graph. Okay, that's your graph. Ah, okay. So no, I think I got carried away. I did a mistake. Can you tell me where did I do a mistake? Can you find a mistake in this graph? I actually chose the wrong one for this part. It's not the right one. It's actually the left one. This is the one for concave down. We had concave down, right? Yeah, we had concave down. Yeah, I was wondering because this graph doesn't look right. Because I know how does the graph look like because I picked it. Yeah, so this is this one. This one. Can you see why? Because for this one, it's 0 somewhere here and it's actually getting increased, right? It's actually getting increased. So this is for concave up. This is for concave down. So graph will look like this. Yeah, now it looks right. Initially, if you remember, I actually draw like this, not like that. It's actually like this. Okay, any question from this one? As you can see, if you know all the informations and if you know how to use it, it is really fun to work with, right? But it's really easy to make a mistake as well. And fortunately, you'll not be asked to draw it. Instead, you'll be asked to choose it from the 4 options, which is much easier because you can actually see how does the graph look like, and you can actually start ruling out 1 or 2 options once you start getting these options. Okay.
So it should be concave down until 6 and then concave up after, correct?
Not 6, it's up to 9.
But the second derivative is 0 at 6. So shouldn't that be an inflection point?
Okay, that's a good point. Didn't I check that? As I said, there are so many things, and that's why it's really easy to get carried away. Okay, let me check. Yeah, the second derivative is 0, definitely at 6. But this doesn't mean we need to have an inflection point. We need to check. Let me see. Yeah, good point. Very good point. We may not have an inflection point. We have seen examples of that.
Because if you put 5 in to the second derivative, it's negative, which means it would be concave down.
It's equals 6. Yeah, that's a good point. I think we should try this. Yeah, right. So at x equals 6, that means from 3 to 6, we can check, and from 6 to 9. Because we already know what's happening from negative infinity to negative 3, and we know what's happening from 9 to positive infinity. All we need to check is these 2 intervals. We have picked up 5, right? And it was negative. So it will be concave down for this part. And if we pick any value from this, yeah, I think if we pick 7, let's say, so 42 minus 36, yeah, it will be positive. You're right. There will be a change of direction somewhere here. Yeah, you're right. But again, that's that will be not that required because you need to choose it from the graph. But yeah, when you are trying to draw it, yeah, you'll have a change of concavity here at 6. Let's say that's my 6. So it will be concave down up to this and concave up from here. Yeah. Oh, it is actually concave up when I have drawn this, but I didn't really calculate it algebraically. Thanks for pointing it out. And you can see it's easy to get carried away because there are so many things you need to pull up together, and obviously you need to know how does this behave. Okay. All right, now I think we're done. Yeah, any question from this? And sorry about that. I should have calculated it for you. Any question from this? Do you feel that you can actually do this? Do you feel that it's doable? Is there anyone who thinks that it's really hard or it's going to be difficult to do? Obviously, it might be difficult if you have a fraction, you have more things to do, you have to find the vertical asymptotes, you have to do, probably more intervals and all that. But do you still think it's doable? That's the question. Okay, now I'll post a homework for this part of the graph. And again, you'll not be asked to draw the graph, although it would be really nice. It would have been nice if I gave you options to draw this graph. But since we have a really smallish semester, I'm not going that direction. Instead, I'll give you options. You just need to pick it from those 4 options. And the funny thing is, when you have options, you will see once you start picking up the informations, once you start calculating the informations, you will see it will help you to rule out 1 or 2 options. Okay, that would be a really nice thing when you have options. All right, so let's take, already we are 10:16. Oh my God. You can see how much time it requires, right? Okay, so let's meet 5 minutes. Let's take a 5 minutes break and meet after 5 minutes. So I'll take a break. When I say this word optimization, what's the meaning you can derive from it? It doesn't need to be a mathematical aspect. What do you understand by this word optimization?
It's like the most effective something can be.
Yeah, very good. Most effective, we can say that. So the thing is, on this part of the lecture or discussion, we'll try to maximize profit or maximize things where it's profitable, or minimize where it's costing us. That means where it's taking something from us, we'll try to minimize that. And where we are getting something, we'll try to maximize that. Okay, that's another way to say optimizing it. Okay, optimization of those. So for example, if we are doing a business and we are getting profits from it, we'll try, when I say optimization of that, I'll actually try to maximize the profit, right? Or in the other direction, when I'm buying something, when it's costing me something, when I'm saying I'm trying to optimizing that, that means I'm trying to minimize the cost, right? So let's see what we actually mean when I say excuse me, when I say this optimization and all that. and I'll definitely pick one example first, and then we'll go back to the guidelines. Okay, let's say of all rectangles with a perimeter, let's say we have rectangles. It doesn't look like a rectangle. Sorry about that. Okay, now let's say we have rectangles with perimeters. Okay, with perimeters, let's say 100. Okay, that's the perimeter. And let's say we have a couple of other rectangles with the same perimeter. Now for understanding that, you need to understand what is a perimeter. Can anyone tell me the perimeter? I mean the definition of perimeter, I should say. How do you define a perimeter for a rectangle? How do you define a perimeter in the first place?
Be like 2x plus 2y for
Uh,
each of the sides.
yeah, that's for the rectangle, but my question is, how do you define it generally? I mean, when
Isn't it like the length around all of the sides put together?
Exactly, very good. That means you just add all the sides. That's it. That's the perimeter. Doesn't matter what is the size of what is the shape of the object you have. If you just add all those sides, that's it. That's your perimeter. Okay. Now the question says you have a couple of rectangles of the same perimeter. Let's say that's 100. How that could be possible? It could be possible because your rectangle could shape like this, right? It doesn't mean that your length and width has to be of the same size. As long as the perimeter is 100, it actually satisfies our requirements. It has to be a rectangle and the perimeter has to be 100. That's it, nothing else. So it could be like this, or it could be like some other size. As long as they are rectangles and their perimeter is 100, we are fine with that. So the question says, of all rectangles with a perimeter of 100, which one has the maximum area? Which one has the maximum area? Now you might be wondering, hey, if the perimeter is the same, shouldn't the area be same as well? And the answer is no. If you have a different shape, let's say square. Okay, let's say square. That means if you have a square, let's say like this, okay, it's 25 everywhere. The perimeter is 100, right? If you add all those, and let's say you have 10 here and 40 here, that's still 100, and both of these are rectangles. Do you agree? But if you look at the area, okay, let me go back to the formula as well. What's the area? What's the formula for the area of a normal rectangle? What's the area? If you have, let's say, length as x and width as y, what's the area? Anyone?
Isn't it x times y?
X times y. Very good. And what's the area of a square? If the sides are, let's say,
X squared.
Yes, okay, is squared. Very good. The side squared, right? So if we just take a look at these two rectangles, obviously square is a rectangle, but it has a precise name, which because it has the sides equal to each other, right? Okay, so on an additional term with this is we have a 90-degree angle here as well, because for rhombus we have the sides equal to each other as well. Anyway, I guess you know this geometrical shapes and all that, but we'll definitely see examples of different shapes, and we'll go back to the perimeters and areas of all those. Okay, now if I find the area for the rectangle here, it will be 40 times 10. Do you agree? It's just the area of the rectangle. And if I find the area of the squared, it's 25 squared, which is 625. Can you see, even though the perimeter was same, it doesn't mean that your area has to be the same, or rather area of both of these have to be the same. It could be different. So if you're wondering that why they are telling that of all the rectangles with a perimeter 100, which one has the maximum area? If you're wondering how can it be different, here is your example. It can be different. Do you agree? Okay, now let us go back to the problem we had. We had the perimeter 100 and we're looking for the maximum area. Okay. So first of all, our question might tell us, write the area in terms of the width y. Let's say I have given you the width y. I have given you the perimeter 100. That's my width. My perimeter is 100. And I'm telling you, the first part of the question is, obviously we're trying to find the maximum area, but we are slowly building towards it. Okay. The first part of the question might say, hey, write the area in terms of the width y. What should you do? Can you imagine anything from the informations you can eyeball? We can't really write x times y here, because it has told us to write it in terms of y. That means we can't have any other variables other than y. We can't have x here. We can't have anything other than y. What should you do?
So should you write the minimum values that y could be and then the maximum values?
Oh no, we're not really trying to find the minimum or the maximum here. We're trying to write the formula for the area. We are not yet there to find the minimum or maximum. We're just trying to write the formula. We know the formula though, it's x times y, it's length times width. But the question says we need to write it in terms of the width. We can't have any other variables. And for that, we have this clue, which is the perimeter. And let me show you how. So we know if the length is x and the width is y, the perimeter is, let me write it this way, 2x plus 2y, right? Do you agree? It's the perimeter, right? And it's 100. We know that. And the question says we need to write the area in terms of y. That means it needs to something times y. And that needs to be as in terms of y as well. We can't have x. We definitely know it's x times y, where the width is y, but we need to replace this x by some values of y. How can you do that?
Can't you just do length times width?
Like this?
Like with an L, maybe? I don't know.
No, as I said, we can't have anything other than y here. We need to express this in terms of y.
Could you do like the perimeter, like say like P or something minus 2y?
So I can understand what you're trying to say here. The thing here is, since I'm trying to replace this x by some values of y, all I need to do is find the value of x in terms of y from this equation. That's it. So it will be 2x equals to 100 minus 2y. So my x would be 100 minus 2y times over 2. Now I can replace this x here. And you can see this is all about y. We don't have any x here. So it's 100 minus 2y over 2. That's my formula for the area using y. As I said, we can't have any other variables other than y. That means if I reiterate it, for this length, you need to find the value of length in terms of y, like this. Any question from this? Take your time, okay? If you have any question, you can ask. No questions at all? Is there any question from this conversion part? I mean, I've just expressed my x with the help of y. Or in other words, I might say I have solved x, solved the equation for x, and then replaced it into the equation of area. Any question from this? No question at all? I can't see anything in the chat. Yeah, so looks fine to me. Okay. All right. So now we have the first question, first answer. The second part of the question might ask you the interval of interest. We have seen this phrase before, right? The interval of interest. That means when we try to draw a graph, the interval of interest was where do we want to draw the graph? That means we want to draw the graph for in a certain interval in some cases, right? We don't need graphs for all the intervals. Often we define a certain length that, hey, I want a graph from 0 to 3. So that's my interval of interest, right? Something like that. So what's the interval of interest here? Obviously, the length cannot be negative, right? Definitely it will start from 0, right? And how far can it go?
Up to 100?
Well, the area.
Up to 50.
And why do you think it should be 50?
Because this is for the side length.
So first of all, for the perimeter, as we picked 100, right? Yeah. So even if we pick the highest in one direction, let's say like this.
Oh, it would be 48. 49. 48.
Even if we pick like this, I didn't draw it right, but you can see it's a rectangle. Even if we pick like this, let's say half and a half, okay, or even a 0.1 or 0.1, right? This length cannot exceed 50. Can you see that? Do you agree with that in the first place? Because overall it's 100. So if one of these is more than 50, then how can the total be 100? This length has to be within 50. Do you agree? I can go really, really small with this. Maybe I can pick a point 0.00001 for each side, but this length still cannot be more than 50. Do you agree? Because I know that if I add all the sides, all these 4 sides, 1, 2, 3, 4, the overall length is 100. And I know this side and this side will be equal. If the total is 100, can either of this side be more than 50? Just try to imagine, try to understand it. Does it make sense when I say, or when I think, sorry, I couldn't notice your name, when I say it cannot exceed 50? Do you agree with that? Is there anyone who is still confused what's going on here? Let me know, okay? Just try to imagine this, that you have 4 sides and all the opposite sides are equal to each other. That means this side is equal to this side. If the total of the 4 sides, if you add all those, is 100, can this side separately be more than 50? If this is, let's say, if this is 51, that means this will be also 51. So the total is already more than 100. So it can't be more than 50, right? Okay. Hopefully it makes sense. If it doesn't, please let me know. The next question is, we need to find the, as the question said when we started, we need to find the maximum area, right? Now, how to find the maximum from this? How to find the maximum from this? We just know 2 things, probably 1 thing, to be honest. You can say 2, that it's a rectangle. We definitely know this, and the perimeter is 100. We know nothing else. And from this, we want to find the maximum area. What should we do? Can you imagine anything? Have you seen anything from the discussions we have had so far? Obviously, yeah, at the back of your head, you might be thinking, hey, where is calculus here? All we have done so far is a little bit of geometry and a whole lot of algebra. Where is calculus here, right? Why do you think we can use calculus? Obviously, it's a calculus course. I can't really do algebra all the time. There has to be some part with calculus somewhere in between, right? Can you see any place where we can actually use calculus? Anyone? We're trying to find a maximum value, right? Where have you seen this in calculus? That's the first question. Finding maximum or minimum of something. What if I say in the slide, minima and maximum? You have seen this, right? we have seen this slide with minima and maxima. We have seen how to find minimum and maximum. Do you agree? Now, I have already given you the hint. Where have we seen this? Now, can you imagine what should you do?
Find where the first derivative of the area equation equals 0.
Okay, very good point. And if we can do that where it's 0, then what is the outcome from that? I mean, where it's when it's 0, does it give us the maximum value? You're almost right. Yeah, you're doing it very good. So yeah, first of all, we need to find the first derivative and set this to 0. Okay, then we'll see what's next. If you remember, when we try to find the minimum and maximum value, the first thing we needed to do is to find the first derivative of the function. Do you agree? Okay, now as we know that we are trying to find the first derivative, now the question could be, hey, where is the function? I need to find the first derivative, but of what? Can you locate anything? Where is the expression which we can use to find the first derivative of?
We use the area formula.
Exactly. We're trying to find the maximum of the area. So this is the equation or expression, I should say, or function, in other words, we need to find the derivative of. So let's say we have a equals to y times 100 minus y. No, I think it's 2y. Yeah, over 2. Isn't it 2y? What's that? Yeah, it's 2y. 100 minus 2y over 2. Okay. Now, I can do this way. I can rewrite it as half times 100y minus a 2y squared. Okay, so that it looks good. Okay, a fraction often creates psychological fear in you, right? Often it's difficult to work with, but when you see a polynomial, often it actually makes your life easier to start with. It gives you a head start. Anyway, now we're definitely looking to find the first derivative of it, but the question is in terms of what? In terms of what? In terms of x, is it? Or what?
Well, in this case, it'd be in terms of y.
Exactly. The expression, the function is in terms of y. So the derivative has to be in terms of y. Very good. So the derivative of 100y, what's the derivative of 100y in terms of y? Anyone? Again, this is the calculus part.
100.
100, very good. And for 2y squared, someone else?
4y.
4y, very good, yep. 4y. Because for y squared, we'll have a 2y, and here's another 2 multiplied to it. So it's a 4y. And of course, now you have guessed it right. If you have, of course. Now we need to set this to 0. Because for finding minimum and maximum, we first find the first derivative and then set that to 0. So half 100 minus 4y equals to 0. It's 100 minus 4y equals to 0. So 4y will be 100. So y will be 25. Okay. So y will be 25. That means the width will be 25. What about the length? We can easily find it from this expression, right? We have already expressed the length in terms of the width. So let's find that. So x equals to 100 minus 2y over 2. It will be 100 minus 50 because y is 25. It's 25 as well. So the length is 25. The width is also 25. What does it tell us? What's the shape of the rectangle?
Square.
Very good. And actually it makes sense because I have actually showed you this problem. Yeah. For a rectangle, for different shapes of the rectangle, you get the highest area for a square always, obviously of the same perimeter. The square always gives you the highest area. And we have successfully defended that because our length and width gives us an idea that it should be a square. I should have tried different values though here, but anyway, it makes sense. Whenever you have a rectangle shaped object, if it's a square, it will give you the maximum area. That's actually the general idea. And we have successfully defended that. Isn't it fun to work with? But again, you have lots of things to combine here together to find one single solution. First of all, obviously, you need to know the the formula of different shapes, the formula of perimeter, the formula of area of different shapes, square, cube, cylinder, cones, what else? Triangle, circle. You need to know the formulas of this. That's the first thing. Then you need to know how to do this. Obviously, since you are looking for the minimum or the maximum value, you need to find the first derivative and set that to 0. So geometry, algebra, and calculus in a single problem. Isn't it fun? All right. Any question from this? Any question, even if it's really, if it sounds stupid to you, doesn't matter. Just feel free to ask questions, okay? I'm repeating this because I know you will, hopefully you will not, but in most cases you will definitely have questions once you start doing it in the homework. Okay. So
This is just kind of a stupid question, but like for the equation where it's 100, whatever the perimeter is, that's what we're going to put in there, or is it always going to be 100?
where?
Where it says, if
Here?
you go down, yeah, x equals 100 minus 2y over 2.
Like this one?
100 would be the perimeter, yeah.
Oh, well, yeah, whatever the perimeter is, yeah.
Okay, that's what I thought.
Yeah, it could be 200, it could be 50, it could be a fraction maybe, because a perimeter can be a fraction, whatever they give you in the question, yeah. I have picked 100, that's why, because 100 is always easier to calculate. So yeah, they'll definitely, in the homework, they will definitely give you some bizarre value, because I don't give a certain value in the homework. What I do, I give them a range. I actually give them a range, and they randomly give you a value from that. Because you are 28 in total, they try to give you 28 different values, right? And even when you do it second time, I guess the value gets changed, right? I think so. I'm not sure because I haven't done this um, in the homework, or rather as the homework.
Yeah, it does.
Yeah, it should. Because in our days, obviously it was, there was no COVID, so all we did is the handwritten assignments. So we haven't really done this, but as an instructor, I have done this a couple of times, but yeah, the value should get changed. And the reason is quite simple. I actually give them a range, and from those values, they actually randomly pick one for you, for all of you. Anyway, yeah. So I think we have enough time to see at least half of the next problem. Let's go for that. Or let me see. Okay, so one more thing before I forget. So before we meet tomorrow, your pre-class assignment would be to see the formula for all the shapes. Formula, you can see it from the book. I think the book would be a really good reference. Go back to the book, see which shapes they have used mostly.
Did his Zoom just crash?
Can you hear me now?
Uh.
Can you hear me?
Yeah.
Oh, I think I got disconnected, right? Yeah, I think so, because I can see the Zoom was trying to reconnect me. When did it happen? What's the last thing you had?
You said your pre-class homework will be.
Oh, okay. So
We heard nothing.
You haven't missed too many. Probably a fraction of a minute. That's good. Anyway, yeah. So the pre-class assignment would be to see the formula of different shapes. So I would recommend you to go back to the book because that would be a great reference for you. Okay. If you go back to the book, you will see they have used different shapes, different objects for different problems. So it would be easier for you to pick which shapes, which formulas you need to know. So before we meet tomorrow, just go over those formulas. I don't want you to memorize all of those right now. If you can note those down, if you can have those in front of you when we discuss those problems tomorrow, that would be nice. Okay. All right. So let me quickly come back here. Okay, can you see the screen I'm sharing? I hope you were able to see it. Just give me a thumbs up so that I can reconfirm it. Can you see the screen? Oh, is it disconnected again? No, not.
We can see it.
Okay, thanks. Because I thought it got disconnected again. Anyway, yeah. So let's see this. Oh, I don't think this is the slide we need. Where is optimization? Yeah, here is that. Okay. So I'll try to cover at least half of this problem, and hopefully we'll finish it tomorrow. So let's say you have a field which you want to fence. In some places you want to fence, you want to create a barrier in some places. For example, to separate your cattle, you want to separate using different categories, and you don't want one of these to get mixed with each other. So you will create a barrier with fence, okay? And let's say you have a field of length y, okay, of this length. And we're trying to minimize the cost of fencing, okay? We're trying to minimize the cost. So what we'll try to do is we'll try to find a way which will take less amount of fence, whatever the material is for the fence, okay? And let's say I want to fence the boundary, I mean the two sides, and in between I need to have two more of the same length. That means, in other words, what I'm trying to say is I want to subdivide the entire field into 3 equal halves. Or I shouldn't say equal. Let's say I want to subdivide it into 3 parts, three parts of this length. Okay. Now, let's say I have a fixed amount of net to make the fence. Let's say it's 400 meters. Okay, let's say it's 400 meters. It's not too much when you're trying to make a fence, though. Let's just imagine it. The number doesn't really matter. So we want to keep this side open so that I can enter, or the cattle can enter this burn. Okay, so that means I want to make a fence on the 3 sides of this rectangle and 2 in between. So the question now would be to set up the equation, set up the function, I should say, first of all. So we need 4 of these lengths. First of all, do you agree with this? We need 4 of the same length. As I said, we'll make fence around the 3 sides and 2 in between in this direction. Let's say if it's in this direction, if this side length is x, if this side length is x, then if I make a fence like this in between anywhere, shouldn't it be x as well? Try to understand it. Don't really trust me. Try to feel this, because this picture will not be given, may not be given. You may need to visualize this at the back of your head, or you may do it in the scratch paper. The question might not provide you with this image of this. So it will be difficult to visualize once the image is not given. So that's why I'm saying try to understand why is that, or why it's happening. Do you agree when I say that I need 4 of this length x? I'm trying to fence, by the way. So I need to create a fence where I need 4 of the same length x. Do you agree? And of course, 1 of this length y. I'm creating a fence here as well, and I have already said the length is y. So if it would be wrong if will it be wrong if I say I need to create a fence of total length 4x plus y? Will it be wrong? Remember, it's not the perimeter, so you can't really add all the sides. It's still the total length I need, definitely, but it's different than perimeters. The total length where I need to create the fence is this 1x, 2x, 3x, 4x, right? 4 of this x plus this y. Do you agree? If you agree, I'll show you a problem like this when we meet tomorrow. If you don't agree, let me know tomorrow when we start, okay? And again, a quick suggestion would be go over worked out problems like this in the book, okay?